Hello, my name is Chi-O, and I'm glad to introduce you to the JGR paper that culminated from my PhD and postdoc work at the University of Oxford, in collaboration with colleagues at the Universities of Lorraine, Leeds, and Potsdam. The title of the paper is Large-Scale Interseismic Strain Mapping of the Northeast Tibetan Plateau from Sentinel-1 Interferometry. High-resolution strain rate mapping can inform active tectonics and seismic hazard. In this paper, we present 100-meter resolution INSAR east velocities derived from 5 years of Sentinel-1 data over the northeast Tibetan Plateau. We also derived the first of its kind 1 kilometer resolution strain rate fields for the area, including the second invariant, the dilatation, and the maximum shear rates. The high-resolution strain rate field allows us to visualize the strain partitioning between the faster-sloping Haiyuan fault and the slower-sloping Gulang fault. The shapes of the velocity profiles can also help identifying creeping sections. The extent of the creeping sections can be mapped out in strain with their extreme strain rate values. In this way, we can systematically identify unknown creeping sections, and by comparing this with the seismicity, we can tell apart interseismic creep from any coseismic or postseismic signals. Comparing the dilatation and the maximum shear rates, we can see the full length of the strike-slip Haiyuan fault and how this shear motion transitions into shortening between the Qilianshan thrusts. The focused contractional strain at fault branches also alludes to the volumetric changes at the triple junctions and supports the role of fault geometry in concentrating strain. Some strain features do not align with any known faults. This particular one stems from the shear motion on a secondary branch of the Haiyuan fault and is derived as a result of the sharp gradient in the east velocities across the valley between the Chuushan and the Yellow River. These features prompt us to take a closer look at the topography, from which we spotted diverted drainage and a back-tilted fan surface. These observations together point to the possibility of a fold or a buried thrust fault developing underneath the valley. So far, we have demonstrated how we can use high-resolution strain rate fields to illuminate strain partitioning and transitioning, and how they can play an important role in discovering creeping sections and unknown active structures. On the other hand, the vertical velocities contain signals from a wider range of sources, including climatic, hydrologic, and anthropogenic, which makes dynamic modeling studies more challenging if they require vertical velocities as constraints. If you are interested in how we mosaicked and referenced the independently processed INSAR velocities, or how we chose our filtering strategies for strain rate calculations, please visit our JGR paper and feel free to email me for further discussion. Thank you for watching.